Have you ever wondered what happens when a legendary brand, a name tied to the highest level of engineering for more than a century, suddenly disappears from every major conversation? Not because it failed, not because it gave up, but because it was quietly building something massive. That is exactly what happened to Rolls-Royce over the past several years. While Boeing and Airbus were fighting each other for global aircraft orders, while GE Aerospace was holding press conferences to show off thrust records, and while the entire aviation industry was drowning in the heavy aftermath of the pandemic, Rolls-Royce almost vanished. Thousands of workers were laid off, contracts were canceled, its stock price collapsed. Financial media outlets were already writing early obituaries for the brand. Everyone thought this was the sign of a company slowly fading away, and they were completely wrong, because while the world stopped paying attention to Rolls-Royce, that was exactly when the company began the boldest project in its 120-year history. Not a minor upgrade, not a concept drawing meant to impress people, but a fully working prototype, a machine that had already been tested in the real world and had passed every test with results so shocking that the aviation industry had to sit down and read the numbers again and again just to make sure they were real. They call it UltraFan, and that name was not chosen by accident. UltraFan is not just better than the previous generation of Rolls-Royce engines. It goes beyond almost everything commercial aviation has ever known. 25% better fuel efficiency, the largest fan ever fitted to a commercial aircraft engine, an advanced gearbox never before seen on an engine of this size. And most importantly, it has already been tested in real conditions with verifiable numbers, not just promises on paper. But here's where the story gets really interesting. UltraFan is not just a more powerful engine, it is a strategic statement, a direct strike at the future of the entire industry. A challenge aimed straight at GE, Boeing, and anyone who ever believed Rolls-Royce was finished. So, what is hidden inside this machine that makes it so special? Why are the world's biggest airlines watching every new move from Rolls-Royce so closely? And is this really the turning point that could completely reshape the aviation industry, or just another big promise from a brand trying to make a comeback? That is what we are going to find out in today's video. Before we get deep into this story, if you enjoy detailed analysis videos like this, make sure to subscribe right now so you do not miss what comes next. The aviation industry is standing at a crisis crossroads. To understand why UltraFan matters so much, we first need to look at the bigger picture. Commercial aviation is facing a double crisis unlike anything in its history. On one side, there is enormous economic pressure. Fuel can account for more than 30% of an airline's total operating costs. With each aircraft staying in service for decades, even 1% of fuel savings can create millions of dollars in difference every single year. Airlines do not simply want more efficient engines, they need them in order to survive. On the other side, environmental pressure is rising faster than ever. The European Union has been implementing the Fit for 55 program, a tough package of policies aimed at cutting carbon emissions by 55% by the year 2030. The International Civil Aviation Organization, or ICAO, is setting mandatory global emission limits. Some major airports in Europe and Japan have already started adding extra charges to flights that use older generation engines. This is no longer just a soft incentive. This is law. And airlines that fail to adapt will face both financial penalties and the risk of losing landing rights at some key airports. On top of that, there is another issue people talk about less, but it is becoming more important every year: noise. Communities living around airports in the United Kingdom, Germany, the Netherlands, Japan, and several U.S. states are pushing regulators to limit flight hours and flight numbers. Some airports have already imposed full nighttime flight bans. Louder aircraft mean fewer takeoff and landing slots, and fewer slots mean lower revenue. In short, the entire economic structure of aviation is being shaken from the ground up. Engine technology from the previous decade, no matter how efficient it looked by the standards of its time, is becoming less and less suited to this new reality. And this is the exact gap Rolls-Royce is targeting. But to understand why that matters so much, we need to look directly at the heart of the story, the machine everyone is talking about. What is UltraFan, and why are engineers so impressed by it? Rolls-Royce UltraFan is the result of 4 decades of accumulated research. But do not get it wrong. This is not just a step-by-step evolution of the earlier Trent family. This is a completely new design, built from the ground up with an entirely different philosophy. Let's start with the first thing you notice, the enormous fan at the front. UltraFan's fan has a diameter of 140 inches, about 3.56 meters. It is the largest fan ever built for a commercial aircraft engine in history. But size is not the only thing that makes it special. What really matters is how it is made. Each fan blade is made from carbon composite material, which is much lighter than titanium. But to survive impact, for example, if a bird accidentally flies into the engine at high speed, the leading edge of each blade is reinforced with titanium. The result is a blade that is light, strong, and flexible enough not to shatter when something unexpected happens. In aerospace engineering, this is what people call a win-win rare, but when it happens, it is worth paying attention to. Next comes the bypass ratio, a technical term, but an extremely important one. Imagine it this way. In a jet engine, not all the air passes through the engine core and gets burned. A large amount of air bypasses the core and creates thrust by being accelerated directly through the fan. That air is called bypass air. The higher the bypass ratio, the more efficient the engine becomes, and the quieter it usually is. UltraFan reaches a bypass ratio above 15:1. That number has never been seen before in a large commercial aircraft engine. For comparison, the best modern engines today are around 9:1 or 11:1. Rolls-Royce has pushed far beyond that limit. But the most impressive number in this entire story is not the fan size, and it is not the bypass ratio. It is 64 megawatts. That is the amount of power UltraFan's central gearbox successfully handled during testing. 64 megawatts through a single gearbox, a world record, recorded and verified under real-world conditions. To make that easier to understand, that is roughly equivalent to the power of 85,000 standard cars being pushed through a drivetrain about the size of a small truck. This gearbox is the soul of UltraFan. It allows the fan and the turbine to spin at their own optimal speeds instead of forcing both of them to rotate at one compromised speed. It is like the difference between a car with only one gear and a car with a multi-speed automatic transmission. Efficiency improves dramatically across all flight conditions. And finally, inside the engine core, where temperature and pressure reach the limits of physics, Rolls-Royce uses ceramic matrix composite material, also known as CMC. This material can withstand temperatures far beyond what traditional metal alloys can handle. That means the engine core can operate at higher temperatures, produce better thermal efficiency, and reduce fuel consumption even further. CMC is also lighter and more durable over time, which helps reduce maintenance frequency. None of this is just theory. It has been tested, it has been verified. UltraFan is a real working prototype, not just a demonstration model. At first, these may sound like interesting technical improvements, but the combination of all these technologies is what could change the entire game, and here is why. The real breakthrough is not technical, it is economic. When engineers talk about UltraFan, they talk about bypass ratio and CMC. But when airline executives sit in a boardroom and ask questions about UltraFan, they only want to know one thing. Is that number real? That number is 25%. UltraFan delivers 25% better fuel efficiency compared with the Trent XWB, currently the most efficient engine in Rolls-Royce's commercial portfolio and widely considered one of the most efficient engines in the world. This is not a comparison against an engine from 30 years ago. This is 25% better than one of the best engines available today. Now turn that number into money. An Airbus A350 flies about 3,500 hours per year on long-haul routes. Average fuel costs for this type of aircraft are around $15 to $20 million per year, depending on fuel prices and route structure. If UltraFan reduces that cost by 25%, that means a saving of around $3.75 million to $5 million per aircraft per year. A major airline operating 100 long-haul aircraft? Now we are talking about savings of up to $500 million a year from fuel alone, and that is only the starting point. Ultrafan's modular design means fewer exclusive components, shorter maintenance time, and lower spare parts inventory costs. Better control of operating temperatures means less wear and tear, extending the time between major overhauls. Built-in predictive analytics can detect potential problems before they become failures, reducing expensive unscheduled maintenance, reducing canceled flights, and reducing passenger compensation. Then comes carbon tax. The European Union has already started charging for carbon emissions from flights. An aircraft that burns less fuel produces fewer emissions, which means lower taxes. As this policy spreads and current trends strongly suggest more efficient engines will not just be a competitive advantage, they will become a survival requirement. And do not forget the noise factor. Airports like Amsterdam, London Heathrow, Frankfurt, and Tokyo Haneda are tightening noise restrictions. Louder aircraft lose nighttime slots. Losing nighttime slots means airlines cannot fully use the earning power of certain routes. Ultrafan, with the highest bypass ratio ever achieved and a low-speed fan design, is one of the quietest engines ever tested. That opens the door to more airports, more slots, and more revenue. When you look at the full picture, Ultrafan is not just an engineering achievement, it is a financial tool, a competitive weapon, and an insurance policy against increasingly strict regulations. Airlines understand this, and that is why the industry conversation is changing. But no matter how good a technology is, it cannot sell itself. And Rolls-Royce understands that if you want to change an industry, you need more than a superior product. You need the right alliances. Challenges and unanswered questions. At this point, if you think this story is just unlimited praise for Rolls-Royce, we need to stop and look at reality. Because Ultrafan is still facing serious challenges, and ignoring them would not be honest. The first challenge is time. Rolls-Royce announced the Ultrafan program back in 2014. The most recent prototype testing took place in 2023, but so far, no airline has signed a direct commercial order for Ultrafan. In aviation, the gap between a successful working prototype and mass production can take many years, sometimes a full decade. Airbus has worked with Rolls-Royce to integrate Ultrafan into future propulsion systems, but which aircraft will use it first is still not completely clear. The next-generation airframe, the aircraft designed from day one to take full advantage of the Ultrafan architecture, has not been finalized. That means the supply chain, production facilities, and FAA and EASA certification processes are still ahead. The second challenge is cost. CMC, carbon composite, a 64-megawatt gearbox. These materials and components are not cheap to produce at scale. The initial price of an Ultrafan engine will most likely be significantly higher than current options. For airlines still struggling to recover after the pandemic, the upfront investment is a real barrier, even if the long-term benefits are clear. The third challenge, and maybe the most subtle one, is industry inertia. Aviation is not a place that changes quickly. Every aircraft and engine purchasing decision is tied to maintenance contracts that can last 20 to 30 years. Airlines that have already invested in LEAP or GNX fleets have no immediate reason to switch, even if something better appears on the market. Change in aviation happens by aircraft generation, not by financial quarter. And finally, there's a question no one has answered completely. Is Ultrafan truly ready for large-scale production within this decade? Prototype testing is an achievement. Producing thousands of reliable engines at a competitive cost is a completely different challenge. Rolls-Royce understands all of this, and its answer is the alliance strategy we're about to talk about now. This is where the race becomes truly intense, because Rolls-Royce is not fighting alone, and its rivals are not standing still either. The engine war, GE9X, LEAP, and an order being overturned. To truly understand Ultrafan's position in the bigger picture, we need to look at its competitors. The strongest rival right now is the GE9X, an engine designed specifically for the Boeing 777X. The most impressive number behind the GE9X is thrust. 134,000 pounds of thrust, setting a world record. This is pure muscle, optimized for one purpose: pushing one of the world's largest aircraft into the sky with as much thrust as possible. But the GE9X has a structural problem that even GE cannot ignore. It is tied to a single aircraft. The 777X is the customer for the GE9X, and the 777X is years behind schedule. Commercial certification has been delayed again and again. Some airlines have cut back their orders. That means the GE9X, even though it is technically impressive, is tied to the fate of an aircraft program that is struggling. The second rival is the LEAP family, a partnership between GE and Safran, used on the Boeing 737 MAX and Airbus A320neo. LEAP is selling very well, with thousands of orders. But LEAP is an engine for the current generation, not the next one. It does not have a gearbox architecture like UltraFan, and it does not have the same ability to integrate with hydrogen or hybrid electric systems. This is where Rolls-Royce's strategy becomes sharp. In 2018, Rolls-Royce signed a partnership agreement with Airbus, co-funded by the European Union's Clean Sky 2 research program, a multi-billion euro initiative aimed at reducing aviation emissions. The goal was not simply to test UltraFan as a standalone engine, but to develop it as a complete integrated propulsion system where the engine, the mounting pylon, and the aerodynamic nacelle are designed together and optimized together instead of being developed separately. This is systems thinking, not just product thinking. And Airbus is betting on that for its next generation of aircraft. What Boeing does not have in this equation is worth noticing. While Airbus and Rolls-Royce are building a future architecture together, Boeing is still largely relying on traditional relationships with GE and a technology roadmap that has not been clearly defined. The 777X is delayed. The 737 MAX is still recovering from crisis, and the new midsize airplane project, also known as NMA, has been frozen indefinitely. But to be fair, GE is not sitting still. It is developing the CFM Rise engine family revolutionary innovation for sustainable engines, together with Safran, targeting a 20% efficiency improvement over LEAP. That program is also testing an open fan architecture, an even more radical design that could challenge UltraFan's fuel efficiency in the future. So this is not a simple two-sided race. It is a multi-dimensional competition, and no one can say for sure who will reach the next generation finish line first. So in the end, the biggest question remains. In such a fierce competitive landscape, does UltraFan have enough power to create real change, or is it just another name in an already crowded race? The future is being written by decisions made today. Now let's look ahead. Not next year, but 10 to 20 years from now. By 2035, analysts expect most major economies to have mandatory carbon pricing systems directly applied to aviation. In some regions, this is already happening. Once carbon costs become a fixed part of every airline's financial calculations, engines that burn less fuel are no longer just nice to have. They become necessary to protect profit margins. Sustainable aviation fuel, or SAF, is already being deployed, but it is still more expensive than conventional jet fuel. However, as SAF production scales up and costs come down, engines that are compatible with 100% SAF, like UltraFan is designed to be from the beginning, will become the natural choice. No major adjustment, no need for recertification. Further ahead is hydrogen. Airbus has announced its Zero-E program, targeting commercial hydrogen aircraft by the year 2035. Rolls-Royce, through UltraFan's modular architecture, has designed this system to be compatible with future hydrogen combustion. That does not mean UltraFan will fly on hydrogen tomorrow, but it does mean the architecture is ready to evolve when hydrogen storage technology becomes mature enough. And here's the deepest strategic point in the entire story. UltraFan is not just a product, it is a platform. Its modular architecture allows the same basic core to be adapted for different thrust levels, from narrow-body aircraft like the A320 family to wide-body aircraft like the A350 and future models. That means an airline could operate multiple aircraft types with the same technical system, the same maintenance team, and the same spare parts inventory. This is what fleet planners call fleet commonality, and it can save major airlines tens of millions of dollars every year. For consumers, the impact is not small either. Quieter and more efficient aircraft with lower operating costs eventually mean airlines can keep ticket prices more competitive as operating expenses rise. Long-haul routes to smaller airports, which used to be economically difficult, could become realistic with an engine this fuel-efficient. For the entire industrial ecosystem, UltraFan sets a new benchmark. GE will have to accelerate CFM rise. Pratt & Whitney will have to rethink its GTF roadmap. Safran will have to find a way to close the modularity gap. The entire race will speed up, and in the end, that is good for everyone. Rolls-Royce is not just building an engine, it is building leverage to change the rules of the entire industry. Looking back at this whole story, one thing becomes clearer than ever. This is not a story about an aircraft engine. This is a story about what happens when an old and established organization decides not to compete under the old rules, but to sit down and rewrite the rules. Rolls-Royce, during the years when it seemed the quietest, did exactly that. It did not try to regain market share by making something slightly better than what already existed. It made a bet that the future of aviation would not be defined by who has the strongest engine, but by who has the most flexible, efficient, and sustainable ecosystem. And with UltraFan, that argument is starting to carry real weight. But, and this is important to remember, the future has not been fully written yet. UltraFan still needs full certification. Large-scale production is still an unknown. Airbus needs to decide exactly which aircraft will become the first home for this engine. GE is striking back with CFM Rise. And the market, as history has shown again and again, does not always reward the best technology. Sometimes it rewards the one that arrives at the right time, with the right partner, at exactly the right moment. Rolls-Royce is trying to be all three at once. So the final question, and maybe the most important one, is not, is UltraFan the best engine in the world? The technical numbers already give us a pretty clear answer to that. The real question is the aviation industry ready to change fast enough to embrace it? And over the next decade, the answer to that question could reshape everything from airline balance sheets to the ticket prices you pay, to the amount of carbon released into the atmosphere every time an aircraft leaves the runway. This is one of the most important races in modern industrial history, and it is happening right now, almost completely under the public radar. So, what do you think? Is UltraFan truly a turning point? Or will aviation keep being held back by the inertia of old contracts and legacy systems? Rolls-Royce has already started the journey, but will it actually reach the finish line? Leave your thoughts in the comments below. And if this video made you see the aviation industry in a different way, do not forget to hit like and subscribe, because the story of this next generation engine still has many chapters ahead.